All right, hello folks. So this is our next lesson in the unit and sort of the end of the new material. The stuff tomorrow, which will be the last stuff for this week, will just be putting everything together. So there shouldn't be anything brand new there. And then finally, next week we'll do review the first day, and then I'll give you your sort of test assignment the next day. And that'll be it for the week, and you'll have till the end of next week to submit that. And that will be marked. Okay? So when I do the thing tomorrow, I'll give you another few questions to do. And again, this stuff is tricky, and it's important that you really do know it. Obviously, being at home affords you certain advantages to figure things out. But just to try to remember that this is really to set you up for grade 11, and for those of you that continue to grade 12. This factoring stuff is very important. So if you're just like looking up the answers online, that'll be all great for right now, but then it'll really hurt you next year. So please do your best to try to work on this stuff on your own. Okay, so here's our first 5-minute question. You will notice there are 2 questions. So obviously I'm going to do them one at a time, but I would like you, as always, to pause and try to figure them out for yourself, and at least do the first one. The second one's a little bit tricky, but it's just one extra step that I'll explain in a bit, and then you can pause after that. So please attempt it, the first question at least. If you want to try the second one, you can. So please pause now. Okay, so hopefully you went ahead and paused, and here we go. All right, so first, we have a number out front, so the first thing we do is we see if this number divides into each of these, because we always want a common factor first. And in this case, the 3 doesn't divide into even the 19, so we can't. So we need numbers. So A times C is 3 times 20 is 60, and B is negative 19. So we need to decompose or break apart this negative 19x into 2 terms. So it could be like negative 9 minus 10. But those 2 numbers need to multiply to 60. So I go to the calculator, and 60 divided by 1, 60 and 1, I cannot make 19. Okay, I'm just making sure I'm recording, and I am. 60 divided by 2 is 30. 30 and 2 can't make 19. 60 divided by 3 is 20. 20 and 3. 19's not going to come out of there. 60 divided by 4. 15 and 4. Okay, so 15 and 4 can definitely make 19. We need to make negative 19. So that means that we need, so equals 3x squared. So negative 19, so we need minus 4x and minus 15x. And remember, you can always check if what you did was legal by just adding those 2 together. So negative 4 minus 15 would be negative 19. Now we common factor. From the first 2 terms, I can take out an x, and I'm left with 3x minus 4. Remember, I'm just dividing. And remember, when your first term has a negative, you always take that out first. So that's a big hint for this question. Okay, so minus, I can divide everything by 5. Negative 15x divided by negative 5 is going to be 3x. 20 divided by negative 5 is going to be minus 4. And just like that, I see that 3x minus 4 is in both. And then x minus 5. The zeros for this are 5 and 4 over 3. And then we'll try the next question. Okay, so again, if you haven't tried the next question yet, I kind of gave you a hint there. I really encourage you to pause and try it for yourself. And if you can't, then I'll take you through it. So please pause now. Okay, so remember, step 1, is there something that we can divide out of everything? In this case, 6 definitely doesn't divide into 5 or 4, but we can take a negative out of everything. And if there's a negative at the beginning, just like over here with the negative 15x, we want to take it out. So we take that negative out. We get 6x squared minus 5x minus 4. Remember, taking out a negative or taking out the x over here, it just means divide everything. So now we're going to have a negative out front, and we're going to factor what's in the brackets. So if you couldn't do it to this point, please go ahead and pause now and give it a shot. All right, so a times c, we're just looking in the brackets, is going to be negative 24, and b is going to be negative 5. I go to my calculator. I know if I'm getting a negative, I'm going to need a positive and a negative, but I just ignore it for now. 24 divided by 1. 24 and 1 I can't make 5 by adding or subtracting. 24 divided by 2 is 12. Again, doesn't work. 24 divided by 3 is 8. Now 8 and 3 can make 5. I know that one's positive and one's negative, so it's either plus 8 minus 3. 8 minus 3 is 5. We need negative 5. So it must be negative 8 and positive 3. So I rewrite it equals negative bracket 6x squared minus 8x plus 3x plus 3. And now I'm going to factor what's inside by grouping. So 6x squared and 8x, I can take 2 and an x out of both. 6x squared divided by 2x is 3x. Negative 8 divided by 2 is minus 4. X divided by x cancels. Okay, so 2x. Oh, I feel like I've made a mistake here. What is the mistake? Oh, it was just a silly mistake. If you didn't see what I did here, this should be right here. I just copied it wrong. It's minus 4, so this was plus 3x and then minus 4. I had a different number written there for some reason, and then when I looked it wasn't going to work, and so I double checked and I figured out my mistake. Now from both of these terms I can't factor out anything, but it's really important that you factor out that 1, because if you don't write it there, things are going to get a little messy, and I'll show you what I mean. So I'm left with 3x minus 4. Okay, so this is going to be negative, and then 3x minus 4 comes out of both, and I'm left from this part with 2x, and from this part with plus 1. And you can see if I just wrote the plus sign, I might not have known the 1 was there, and I would have just written plus. Or maybe I would have written 0, but of course there is a 1 that multiplies. And the zeros for this would be negative 1/2 and 4 over 3. All right, so there's the first 5-minute questions. That just, again, as always, just tries to check whether or not you understand what's going on so far. All right, here's today's lesson. First thing I want you to do, this is on your handout, I believe. Just going to make sure the font is different, but there it is. I want you to factor this. Factor 4x squared plus 12x plus 9. Okay, so please pause and do that. And remember, you can do this. I'm not giving you something you can't do. Do that now. Okay, so again, step 1, is there a common factor? Can I take anything out of everything? I can't. So a times c is 36. B is 12. So I need two numbers that multiply to 36 and add to 12. So 36 divided by 1. 36 and 1 don't add to 12. 2. 18 and 2, no. 3, oh, 12 and 3 are 15. Close, but not good enough. 4 and 9 are 13. Again, doesn't work. 5 doesn't work at all. 36 divided by 6. 6 and 6 are 12. Okay, so this equals 4x squared. Everything's positive, so it's plus 6x, plus 6x, plus 9. I common factor the first two terms, I get 2x, and I'm left with 2x plus 3. And if I common factor these two terms, I get a 3, and I'm left with 2x plus 3. I take out the 2x plus 3, and I'm left with 2x plus 3. Well, that's weird. Both the brackets are the same. So the zeros are negative 3 over 2 and negative 3 over 2. You might remember that when we have this, we can write this just like that. Okay, now, you can do that, right? Hopefully you were able to do that already. You might not have got this last step, but hopefully seeing it, you recognize that that's what you could have done. Was there a quicker way to do this? That's the question. Was there a quicker way to do this one? So what I want you to look at the first term, 4x squared, and look at the first factored term, 2x. And then look at the last term, 9. And look at this last term, 3. What's the relationship between 2x and 4x squared and 9 and 3? And if you said that the square root of 4x squared is 2x and the square root of 9 is 3, then you'd be correct. However, if I gave you this, 4x squared plus 7x plus 9, it obviously wouldn't factor to this because they're not the same. So how do you know when one of these things is going to be a nice, easy squared answer? Well, the last thing I want you to do, and in class we would have done a whole investigation, but obviously that doesn't work on this platform. Multiply 2x and 3 together. So 2x times 3 is 6x. And how does that relate to this middle term? Well, when you multiply 2x by 3, you get half of this. So now I'm going to give you the definition for the first part of today's lesson. It's a two-part lesson, and to be honest, on your sort of test thing, I'll have you talk about a perfect square trinomial at some point, but you can factor this old school, and it will work every time. All right, so let's do a few definitions. A perfect square is a number or term that is the product of two identical terms. Okay, so what do I mean by that? Well, let me list some perfect squares. So 1 is 1 times 1, 4 is 2 times 2, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, etc. And we could keep going. But we can also have perfect squares that aren't just numbers. So x squared is x times x. X to the 4 is x squared times x squared. X squared y squared would be xy times xy. And then we can get fancy. We can say 9x squared, because the 9 is a perfect square and the x squared is a perfect square. And we could say 100 x to the 4, because 100 is 10 times 10, and x to the 4 is x squared times x squared. So those are all perfect squares, and you want to try to get good at identifying them. These numbers in particular, up to 100, so it would be 36, 49, 64, 81, and 100. That's just like 1 through 10 squared. Okay, now a perfect squared trinomial is a trinomial that is the product of two identical binomials. So, for example, x plus 2 and x plus 2, if we FOILed that out, we'd get x squared plus 4x plus 4, x minus 5 and x minus 5 is going to be x squared minus 10x plus 25. And let's do 2x minus 3 times 2x minus 3. That's going to be 4x squared. The last term is 9. So let me sort of try to explain this to you now. So if we look at these, x times x is x squared. 2 times 2 is 4. So that's how we get the first term and the last term. To get the middle term, without doing all the expansion, what we do is we take the square root of each of these, so x and 2, and then we double it, and we get 4x. For this one, we take the square root, we get x, and this is 5, and if we double that, we get 10x. But you probably notice that this middle should be negative. And basically, all you need to know for that is if you've got negatives here or a negative here, the middle term's negative. And finally, the root of 4x squared is 2x. The root of 9 is 3. 2x times 3 is 6x. We got to double that. So times 2 is going to be 12x. We've got negatives here, so it's minus 12x. Okay, so I really haven't sort of given you the full lesson yet. I'm just kind of hinting at it. But now I'm going to do two examples that will serve as the lesson. And I encourage you, as always, watch me do the first one, and then you try the second one. Okay, so again, we could do this by decomposition. 16 times 25. So 16 times 25. So we need two numbers that multiply to 400 and add to 40. And you could go through that whole process, but it could take a long time. But instead, when I see 16, I think, ooh, that is a perfect square. So I take the square root of it, and I get 4x. And I see 25, and I say, that's a perfect square. And the square root is 5. But now I have to do a quick check. I do 4x times 5, and then I double it, so times 2. So 4x times 5 times 2. This is going to be 20x, this is going to be 40x. Now, it's there. Okay, so I did that, and it's the same as what's here, so that means, yes, this is a perfect squared trinomial. So to factor it, we do 4x, that's the square root of the first term, plus 5, that's the square root of the last term. I can't stress how important it is that you check this. If you don't check that, this could not be a perfect squared trinomial. I could be trying to mess you up and to catch you making a mistake. And don't let me do that, okay? All right, one more example of this type, and then we move on to the last part of the lesson. I'm trying to make this one quick. I'm already at 16, 17 minutes. So try the next one, and then unpause it and see how I did. Okay, so pause it now. Okay, so for this one, I see 25 and 16. I think, you know what? That is a perfect square. Square root of 16 is 4. And now I do my check. I do 5x times 4 times 2. 5x times 4 is 20x, times 2 is 40x, and then I check. Is that the same as the middle term? Well, it is, but this term is negative. But you know what? That's okay. This is going to work because I just do this. I have 5x. Oh, I made a mistake. On the previous question, that should say squared. Right? We have to have 2. Okay, back to this one. I have 5x and 4. I know it's squared. But if I just multiply these guys together as is, I get 40. But I need to get negative 40. So I put a minus. And the reason is that when you expand this out, the negative 4 times negative 4 will give positive 16. But in the middle, we need a negative. So we need to have these two multiplying to give a negative. And that's it. So this has a 0 at 4 over 5. And both zeros are at 4 over 5. So Desmos. So this is 4x, sorry, what was it? 5x minus 4. All squared. And then you'll see right there, there's only one 0, and it's at 0.8, which is 4 over 5. Okay, so that's part 1 of the lesson. Part 2, I think you will find easier. All right, I want you to factor this. I want you to pause it. I want you to try it. And I'm going to give you a hint right now. So if you don't want a hint, pause it now. My hint is this. If we were to factor one of these, normally we have an x term. So if we don't have an x term, we can say that it's 0x. Now we need two numbers that multiply to negative 64 and add to 0. So I want you to find two numbers that multiply to negative 64 and add to 0. Please pause and try it now. Okay, so if I need two numbers that multiply to a negative, I know that I'm going to have a positive and a negative. And if I have two numbers that add to 0, well, what kind of numbers add to 0? If I said what number adds to 2 to get 0, you would say negative 2. If I said what adds to 3, 3 and negative 3. So we need two numbers that are the same that multiply to 64. So let's do this. Let's go to the calculator and let's do 64 divided by 1. Oh, 64 divided by 1. Doesn't work. Divided by 2. 32 and 2, they can't cancel each other out. Divided by 3 doesn't work. Divided by 4. 16 and 4, they don't cancel each other out. Divided by 5 doesn't work. Divided by 6. Divided by 7. Divided by 8. 8 and 8, well, they're the same. So they would definitely cancel each other out. So this one would have zeros at -8 and +8. Well, that's kind of cool. But is there a quicker way to do this one? I would say there is. I think once we knew that the two numbers that multiplied to 64 were the same, if two numbers multiply by themselves to give a number, then the quickest way to do that is to take the square root of that 64. Okay, so let's make it official, and then we'll be done. A difference of squares is a binomial. Remember, that means two terms, where two perfect squares are subtracting from each other. So the difference means subtract, and of squares means that you're subtracting perfect squares. So x squared is a perfect square, and 64 is a perfect square. We have two examples to try. I encourage you to pause the video and try them, and then I'll do them with you. And then I have two last sort of tips style questions that I'm going to take you through that'll help you with some of the homework. Okay, so please pause and try this now. All right, for the first one here, we have two terms, and they're both perfect squares. Notice I'm just taking the root of the 25 without the minus sign. So these are both perfect squares. So if I'm going to factor this, it's going to be 2x plus 5 and 2x minus 5. To check, I'm going to FOIL. So I get 4x squared minus 10x. Uh-oh, I don't want any x's, but now I've got x's in the middle. I've got minus 10x and I've got plus 10x. But hopefully you figured out almost immediately that these cancel out, and we're left with 4x squared minus 25. So that's correct. All right, this next one, I'm going to caution you because the first step in factoring always is to common factor. So please common factor this and then try. All right, so if you're going to do it, pause it now. All right, so what can I take out of both? Well, I can take a 9 out of both. And I'm left with a squared minus 9x to the 4. And then after we common factor, we always look in the brackets and say, hey, can I factor that anymore? Well, I think I can. Because a squared is a perfect square. The square root is a. And 9x to the 4 is a perfect square. The square root of 9 is 3. And the square root of x to the 4 is x squared. So I'm going to have to move this down a bit. So equals, I have that 9. A few of you forgot to put the common factor out front in my little assignment thing from last week. It didn't count for marks, by the way. Okay, so now we have a plus 3x squared and a minus 3x squared. Okay, and I believe that's everything on your handout. Yep, there's your homework. 230, 5, 6, 7, 11. I am going to do two tip style questions on the next page that I really encourage you to watch as well. Okay, so a few extra. I want you to factor these. Again, as always, I encourage you to try them on your own. The first thing you're going to notice is that both of them are two terms that are being subtracted. So whenever you see that, you should think difference of squares. So if you're going to try them, please pause and try them now. Okay, I'm back. So x to the 8 is a perfect square. The square root is x to the 4. 256, if I square root that, I get 16. So this is going to be x to the 4 plus 16 and x to the 4 minus 16. Now you might think you're done, but that wouldn't make this a hard question. Now we have two things in brackets. Two terms, okay, so maybe it's a difference of squares, but no, it's a plus sign. I can't tell you how many times people think that they can factor this as a difference of squares, but I assure you it does not work. Okay, so this part stays the same. Now let's look at the next part. X to the 4 minus, okay, so these are both perfect squares, and they're being subtracted. So the square root of x to the 4 is x to the 2. The square root of 16 is 4, so x squared plus 4, x squared minus 4. Now, I know that this bracket's done. This is like my favorite question, by the way. I love giving these, and I love making them. Okay, so these, obviously, this is adding, so it's not a difference of squares. This last one, though, subtracting two terms, and they're both perfect squares. So the square root of x squared is x. The square root of 4 is 2, so x plus 2, x minus 2. That's it. You can't go any further than that. If you got that on your own, that's amazing. I don't know if anyone's ever got that on their first try. Okay, last question. Remember, I'm really trying to sort of drive this point home. The most important step in factoring is step 1, and that's to common factor. So is there anything that divides into 50 and 8? 2 divides into both. And is there any variable that I can take out of both? You can take an x out of both. 50 divided by 2 is 25. X cubed divided by x is x squared. Negative 8 divided by 2 is minus 4. The x's cancel, and I'm left with y squared. Okay, now the 2x stays out front, and I look in here. I have two terms. They're subtracting. If they're both perfect squares, then I can factor it. Is 25x squared a perfect square? Yeah. The square root is 5x. I'll write that. Is 4y squared a perfect square? It is. We get 2y. So we can factor this as 5x plus 2y and 5x minus 2y. Okay, folks, that is it for today. There's your homework. Let me post it here. Again, tomorrow I'll come in with the last lesson for this unit, which is putting everything together, and then we'll have review and a test next week. Please don't hesitate to get in touch with me if you have any questions or concerns. Good luck, folks.